And I guess no class today, huh? I can't hear anything. Why? Oh, there it is.
Hey, good to see you guys. Welcome to the last class of the quarter. Yeah, Matthias, welcome back. Awesome. Okay, all right. So, well, like I said in the announcement, I don't know if I posted the announcement, but or maybe I mentioned it before. We'll try and complete this game today, or at least have this animation thing going with lists. I think it should be fun. But the first part is basically going to be you guys recreating the code all the way up to the list class with, I think we just need the push front. Oh, actually, Brandon posted something to do with a pushback also. So you implemented a pushback too, yeah? All right, okay. So why don't you guys get both? I actually didn't look through the code, Brandon. Did you actually use a tail a pointer to do a pushback in constant time, or did you actually have to start at the beginning and go to the end and then do
It was yeah, it was just a separate one I was doing. It was like one of those where you start with you only use the head. There was no tail specifically. You just start from the beginning onward.
Oh, you start from the beginning. So it's a linear operation. So the longer the list is, the longer it'll take to push back.
Yeah. Yeah.
I think that is the reason why the STL vector class does not support a push front. And also I believe that if the STL list class supports push back, I don't think it does. If it does, then I think it will probably do what we're doing in the quest, which is really maintain a tail pointer. Because otherwise, there's no way of going to the end without having to traverse the whole thing. And so that is what that will get around. Anyway, so in our class and in the stuff that we're going to do, we don't need pushback. So we'll just do that, okay? So how about you get everything up to that done? So we have at least Brandon, who has done it once before, who can, have your back. But before we get into that, I want to, address any general questions you guys might have, because I think Lily also brought this point up. Hey, Lily, you're here. Lily, Jen, and Ethan, you should all switch on your cameras too, yeah?
Yeah, I'm here.
All right. So yeah. Getting stuck in platypus, and yeah, well, you have 2 weeks to do platypus, but still, the time is drawing to the close, so it's natural to get, stressed out. And most people do get stuck with platypus, even though they have the logic right. Okay, even though you got the logic right, meaning that, well, this is what needs to happen. Everybody will, get an understanding of what needs to happen. But what actually happens in professional code, as in all the code that you have to write for the quests, is that it is not just for the logic to be right, but it has to be bulletproof, okay? Which means that it should be right under all possible circumstances, even if there's a Martian invasion tomorrow, okay? So that is the level of detail and care that we need to exercise. And so if platypus, fails a mini quest saying, well, you know what, something is out, you got 10 elements instead of 12, whatever it is, what that means is basically, well, I got my next 20 minutes is shot, because I need to pour through the code to find out somewhere where I have an I less than 10 instead of I less than or equal to 10 or something like that, okay? So some corner case where you say, well, what happens if I get no elements as an input? Does my algorithm still work? What happens if I get, the maximum size as an input? Does it still work? What happens if I get, try all possible variations of a demented person trying to break your code? Yeah. So you got to imagine that you release something out there, and there's something as good as ChatGPT. Yeah, some really powerful AI that is just going to break your code, meaning it's going to try every known exploit. So, if you've got a loose byte somewhere, you're basically screwed for life, right? Because once it can figure out how to get in, it can rewrite your source code. So, so all of these things become really, really important. And so what happens is with lots and lots of programming practice, and that I think is the best way to get there. You know, maybe there are other ways to get there, but I think that practicing does result in does result in a noticeable improvement in your knowledge. Even though you say, well, I don't know if it's going to help at all, I'm going to do it anyway, you actually do find it helps. That is a really strange thing about learning in this way. So you have to give equal importance to the practice part of it as to the understanding part of it. So you got to keep at it, run into all of the different bugs, and then imagine every single case in which the quest master is trying to break your code. Okay, so basically you got to think of the quest master as the questing system, the auto grader, as your adversary. Like Richard, I'm never ever going to do another questing thing again. You got to feel like that and say, well, you know what? No matter what I do, this thing keeps breaking it. Right? So you got to say, well, that is my Ganondorf. And so can I get over that Ganondorf? Okay, because that's what I need to get to the next level of Zelda. And so you have to approach it with that tenacity and say, but because you also have to keep in mind that if you've done quest number 6 and do a decent job in the midterm and final, you pass the class anyway, right? So you're not going to fail. But you got to get to that. If you want to go all the way and basically feel comfortable in 2B level material, you got to face the boss and overcome that, which really is to say, when I write something, there is nobody on earth that can break through it. That is the level of confidence you should have with your code. And we just start with small cases. And eventually, as you go on to build professional code, what you'll do is build lots and lots of modules, but each one of those you'll be bulletproof confidence, And so when you put it all together, it'll still be really solid, rock solid code. There won't be any cases where something can just basically fall through the cracks. And that is really what real system design and software engineering pays good money for, because that is really where the real value is, not in putting things together. So it works in some circumstances, okay? Because and so this entire course, whether you do it here or anywhere, if you just persist with it all the way to the end and take programming to the end, and then you can apply the programming skill you got in many different areas, right? So you can go to AI, you can go to data mining, empirical fields, many different areas, but you'll just bring a whole new arsenal of skills with you wherever you go. But you have to get to that place before you move on, is what my feeling is. So I highly recommend all of you. And I think I have a really good chance because all of you are showing up at this lecture. Nobody really has to show up, especially since the finals are next week and all. So I'm glad to see you all and see this level of interest and commitment and everybody trying to do their best. But do not give up with quest number 9. If you've got there, try to get to the end. Maybe it is frustrating. Maybe there's corner cases, and maybe even make it harder for yourself and say, I'm not even going to look up the Reddit. I'm just going to do it on my own, whatever it takes. I'm going to figure out who the genie is, right? The person behind the curtain. I'm just going to figure out without actually knowing how that thing operates, just by sending it various things and looking at the observed output. Right? That is really the essence of machine learning, if you think about it. Anyway, so let's go on to the coding part of it. So what I have in mind today is one of you is going to code. And then, by the way, when you share today, Sophia, you also, right? Make sure you share the online GDB link, or if you don't share the online GDB link, it's okay to post like Sophia did, but I think it has to be posted in, I was saying in Reddit, there is a, when you in the input box, you get to select and say this part is formatted as code. Then it won't mess with the indentation and it'll look like actual code. So you can do that too. All right, so make sure you do that if you're going to code today. Lily, do you want to code today? I think it may be useful. What we'll do is essentially reproduce the code from last class, doing it all the way to So what is it? String list. No. List class. Yeah. And then when you have the list class, we will do, oh, and also the toString. You got to do the toString, and I think there was a bug in toString that one of you were going to fix. Where's Jesus? He was here. But anyway, we'll fix it if it's not done by then. Or maybe Brandon fixed it, or whatever, right? So get the toString working, and then when I join, I'll walk you through the animated, show animated list, okay? And then we'll try and implement the game. So what time is it now? Yeah, 6:12. And it doesn't, it's okay if it goes slightly over today, considering it's the last class and all. Just stick around. If it goes over, I don't think it'll go over. We'll try and finish the game, maybe have a couple of rounds of it, okay? But regardless, whether you stick around to the end of class or not, best of luck for the finals, okay? Like I said, don't feel stressed out. If you do absolutely horribly, email me and get a second chance at the final within the next 24 hours. Not now, after the exam. So, all right, so best of luck with everything, and you should feel free to ask your questions, okay? And the only thing you shouldn't do is share or review your actual quest code with anyone, okay? Co-workers, friends, family, right? Anybody, frenemies, whoever it is, you never show the quest code, because the quest code is a way for you to figure out things. And then if you just share it to someone else, show it to someone else, you lost the opportunity. Okay, so it's just better to retain it. You can ask concept questions and say, how do I do, linking, and do it on a piece of paper like Brandon suggested. You get a very good intuition, even a mental picture of what happens when these things happen. And but never show or share your quest code, right? Don't get answers on quests directly with tutors and so on. Only concepts, I think, that will be the most useful thing to do. Okay, the next quarter, I'm going to rework the participation score thing. We'll experiment in summer and we'll see how it goes. More weight to participation and the demonstration of a person's knowledge in the forums, rather than to the questing. Okay, and the questing will still have some points because of the homework, but there will be more points given to the forum, which is the thing that I can observe and tell more closely that, hey, that person really understands what they're talking about, and so on and so forth. So as a professor, I think it makes more sense for me to allocate more weight to the forums than to the actual quest. But this quarter, since it's in syllabus, that's what we're going to do. All right. But my informal recommendation is just have as much discussion as you want in the forums, right? And, sometimes I may not jump in immediately because I see other people helping. And it's always much more fun to help your classmates, okay, than to help your students, right? I think so. So, if you get a chance to chime in before I do, that's fantastic. It doesn't mean that I'm not reading your posts. Most of the time, I read every single post, okay? Except the obscure comments like, that my feeds tend to miss. I actually read most of your posts, and I actually vote them up too. So that way you also know. So the fact that you're not seeing posts by me or replies by me doesn't mean that I'm not actually reading them. Even your reflections, I read all of them. Including the ones that, including reflections that say, hey, here's my reflection. I don't read the other people's reflections. I don't know what you guys are doing. Yeah, someone actually did that in a reflection, saying, here's a reflection, but I don't read the other people's things. But I actually read every one of them. As within a few minutes of them coming out, I get a notification, right? And then within the next half hour, most of the time, I get an opportunity to just look at it, either on my phone or iPad or the screen. So, and I enjoy reading them. Okay, so it's great fun for me. Right, thank you very much. So how about now, Lily, when you're ready, share the screen. Okay, share the screen and open a private Chrome window. Okay, go to onlinegdb.com. Lily, are you here?
Yeah, I'm here. Let me get my online GDB set up.
Okay, no worries. Okay, great. As long as you're, verbally responsive, then I know that you've got the message. That's okay. How did Google pick up? When I said Lily, Google said hello. Lily, what's the time? Lily, what's the time? Google, what's the time? Lily, what's the time? Oh, it's a hey Lily. Oh, hey Lily. No. Hey Google is how does this the confusability of those phones is not so high that I would suspect that it picks up. Doesn't matter. Not worth spending so much time on. All right, okay. Whenever you're ready, okay? But keep talking, keep talking. Someone should keep talking, okay? Because otherwise it just, the class looks dead otherwise. Not dead, like you guys are still there on the screen, but nobody's talking. It's just, they could have just as well be static pictures. With, AI animation.
I was a little late. She's
Yeah, Mark, no worries. I saw you come in, so don't worry
Oh.
about it. Great. Okay. All right, Lily, Control A, delete everything, dismiss the blue part. I can actually read the font. How is that? Sometimes I'm not able to read the font at this size. Dismiss the blue part. Maybe it's your screen. You got a 4K monitor or something?
No, not a 4K monitor. I think it's a regular monitor. Can you see this better
Yeah,
now?
I could see it even before. But I was thinking back to last class. Last class, I wasn't able to see so whoever that person was sharing. Sophia's screen as well. Yeah, maybe the font is crisper. Anyway, all right. So you dismiss the blue part and put a comment on the top saying today's class we're going to try and complete the game that is based on the string class. Okay, and then you are going to create the not string class. What is it? List class. Okay. No. Today's class is you got to say today's date. No, don't delete the whole thing. Just say instead of today. Yeah, all right. Put today's date there. On the next line, you can say today's date. Okay. All right. Now tomorrow is officially the start of summer. Then, is it? It's like the solstice or something? No, equinox. All right. Okay. The next line, comment, and then I'm going to give it to you guys. What time is it now? It's only 6:20. Okay. How about until 6:35? Now, how about 6:35? How about until 6:40? Okay. 20 minutes. You get 20 minutes. Hopefully you'll be done before then and you'll call me. But you guys should take over and code this up. Oh, maybe last time my screen was half the, even then I can see the screen. That's funny. All right. Okay. All right. So you guys are gonna talk Lily through this code, and then Lily, you're just gonna type it. If anybody who doesn't understand anything that is being called out, maybe Mark or Brandon or someone else is going to call out the code, and there you're going to type it. And anybody who doesn't understand what's going on should just interrupt and say, "Hey, what's going on?" If I can call me back at any time too. Hey, Prof, can you explain this a bit more? I'm more than happy to come in and talk. I don't want to take up as much of your time today as possible because I do want to see the game completed, considering it's the last class and all. So we'll try and conserve the time as much as possible. So 6:30 to 6:35. Okay, aim for that, and try and get the list class done. Is that okay? Can you guys do it? All right, give me a couple of thumbs ups to say that you've got my back here. Okay, and then all right, thank you, Richard. Okay, all right, so you guys are going to complete the class until the list class. Okay, until the list class, and also the main where you're going to test the toString. Okay, and then we'll go from there.
So maybe start by including IO stream and SS stream and using namespace SCE. Is it SS stream or S stream? I forget.
This one's SS stream.
Okay. I just didn't remember how many S's there were.
And then you can put a using namespace STD. Well, I guess we can start by making the struct for a node. So struct node. And then we'll have it have an int underscore data. And then we'll have it carry a node pointer, node underscore next. And then we'll create the constructor node parentheses, we'll pass through into the integer d. And then colon space underscore data d, and then outside comma space underscore next null pointer. And then curly brackets afterward. Okay, so that's our struct. Then we'll make the class list. We'll start by defining like a private and public first. You're gonna want to put them like next to same indentation as class, yeah.
Is the deed how many elements in the structure? Is that what D is for?
D is like the essentially the integer that we just like whatever integer we want to put in there. So it's just going to be like any number that we want. It's essentially because like each node has its data that it carries, which is like what you want the node to have, and then it has the node pointer itself that points to the next node. So that D is pretty much just going to be whatever number we want to put in there. But for class list, so let's also create, I guess, public while we're at it so we don't forget later. Under private, we'll have it have a node, a pointer called head. And then under public, we'll have a list constructor. It's just going to be list parentheses and then with the semicolon after that. And then we'll do a destructor in the same fashion. After that, we'll create list, the first method. So just do a list and then space pointer push underscore front and then pass through the integer d. Yep. And the next line, we'll do a string space to underscore string parentheses, and then it's going to be a const. And the next line is going to be a void show underscore animated underscore list parentheses, and then it's going to be a const. And then outside of that, we're going to go ahead and define the constructor. So do like I guess another line after that curly bracket under, yeah. So then you can type list colon list parentheses curly bracket, yep, and then head equals new node, and then we're going to pass in a -1. And after that, we'll create the destructor now, which is going to have the same setup.
I was like, maybe we should just add it now. Like, we should have a semicolon after the class.
Oh yeah, good idea. Yeah, 28. And then so this one's going to be a while loop, where we're going to say head is not equal to null pointer. And then we're going to create a node called temp. That's going to be a pointer, and then it's going to be equal to head. And the next line is going to be the head equal to head arrow function to underscore next. And then we're going to delete temp afterward. That's it. After that, then we are going to make our push front method. So list and then space. Oh, sorry, no, not the colons yet. Just a space after list. And then the asterisk and then list colon colon. Push underscore front, and then pass in the integer d. And then we'll start the method. So we're going to create an if statement if d is less than 0. Return null pointer. And then afterward, put one more space. Node. And then we're going to create that temp again, but it's going to equal new node, pass in d. Perfect. And then after that, we're going to do temp arrow to underscore next. And then we're going to have that be head. And then head equals temp after that. And then return this. Then after that, we'll create the toString method. This one I'm not sure if I'm using the correct one, so this one might be a little weird, but it is going to be list colon colon to underscore string. It's going to be a const. O string stream OSS. And then after that, we're going to create an if statement. If the head is equal to the null pointer, then we're going to return the phrase headless list \n. And then after that, we're going to create a for loop. If the for the node, we're going to create a node variable just called p. It's going to be a pointer equals head arrow to underscore next. Then semicolon p. Well, p is not equal to null pointer. And after that, we're going to do p equals p arrow to underscore next. And then we're going to do OSS. Left shift. I always keep forgetting this. Yeah, left shift. And then p arrow to underscore data, another left shift, and then in double quotes minus. Yep. And then outside of the for loop, we're going to say OSS, left shift, double quotations, null. And then left shift again, endl. And then after that, we're going to return OSS.str parentheses. I think that should be it if you want to go ahead and create the int main. And from here, I think this is where we need to fix the string method.
I have a question. So why do we have in the constructor, why do I have like initially a -1? Is it because like nothing goes below 0?
Is
Is
this the
anyone know?
first node? And it's
Yeah,
just set
yes.
to
that,
negative
that would be
one.
the first node, but like why would we want a -1? It's like
From the last note that we had there, it was saying that the regular nodes will only have non-negative data items by convention. So I'm thinking it's like almost like a placeholder or something like that to kind of just show that it's like the head at first,
I see.
but I'm not too sure.
You guys done?
So far we haven't fixed the toString method yet, but
Oh, I
we were
see.
also,
Well, you can, yeah, you can go ahead and fix it. That's okay. So we should at least test it to see what is going on. So I can help you fix it if necessary. But I won't fix it. And you guys can fix it, but I can help if necessary.
We haven't written the main function yet.
Yeah, do it. Yeah.
so you can create a list and then just call it my_list. And then we can create a for loop where we'll do an int I equals 0, and then while I is less than 10, and then I++. And then we'll do my_list dot push underscore front, and then put pass I through it. Yep. And then outside of that, we'll go ahead and attempt to see out left shift the my_list dot to underscore string parenthesis, yep, endl, and then return 0.
So it's missing a 9. I think it's because the for loop starts at the pointer is pointing to the next value instead of the data in head.
Yeah, we did not call the constructor. The constructor should have a -1, but we did not pass that in. And then you just denied it's just the head.
It is passed because the -1 is here.
Oh, I saw we need, because in the list, my list, I think we had to use a parenthesis to call the constructor. Otherwise, it's just a data type. Can we try with the parenthesis? Let's try.
We can try it, yeah. I think that when you do it
Oh,
like list my list, it will automatically it'll create an object called my list, and then this automatically calls the constructor, which is why when we run it, there is a -1 node.
oh, where did 9 go?
This I think it's because this for loop starts at
Yeah. Does that
head
mean
the node after the head.
so that means 9 is stored in the head? Is that what we want? Like,
I think so. I think we want to start at the data in head.
oh, just start with head. Just start with head. Without the data. Without the data, because it has to be a pointer.
It's like this.
Yeah. Okay, why is there a -1? Oh, I see. That's the constructor. Well, can we say like while P is not head? Oh no, oh sorry, we start ahead. Um, how about like P to the next is not pointer? Like how it had like P, it's not pointer in the for loop. Um,
Yeah.
yeah. Can we say like while node P equals head, and then P to the next, the
So
P arrow next, yeah. Yeah, like next underscore next. Okay, let's try that. Okay, why is there no?
Well, the null's because she specifically states on line 64 for that.
Oh, I see. Okay. Then I guess it works then.
I think so.
So then like our constructor should have a -1 in there, right? Was that because we start ahead and we just like keep using the next. Does that mean like the -1 was at the end of the list? Oh no, never mind. Yeah. Because we did push from, right? Did we?
Yeah, I think -1 should be
Okay,
at
I
the
see.
end. Yeah.
Is it done?
Yeah.
Oh, let's take a look. Someone should, call me. All right. So what are you doing? Pushing 10 numbers? Okay. And then toString and endl. Okay, so is it and it's printing 9876. All right, great. 0, and then it's doing a push front. I see. So yeah, all right, and up to 9. Great. And we don't have a pushback. Fantastic. All right. So I think that is great. Why did we, does anybody remember why we had the bug last time? This was -1 coming out somewhere. Does anybody remember?
Yeah, we just fixed that.
Right
That was
here
the
this time.
constructor.
Oh, it wasn't the constructor, was it?
Yeah.
I see. All right. Anyway, thank you for fixing that. That was fantastic. All right. So let's go to that animated thing. What is that other method? Show animated list or something. Yeah. So let's implement that. So yeah, copy that and let's implement that. Now let's pick someone else. Okay, Lily. Unless Lily wants to keep going, but I would like someone else to take the screen. I don't know. Maybe Isaac or Richard want more practice. Matthias too, I think. I don't know. Maybe. Anyway, does anybody else want to go, or otherwise, Lily could keep continuing. But anybody like to go now?
I can take it.
You want to go, Brandon?
Sure.
Okay. How come there's nobody else volunteering? Just before you do that, right?
I am willing to go. I was just waiting to see if anyone, I don't feel like I need to
No,
go.
don't wait for like that, okay? You should snatch up these opportunities, because someone else might just say I'd go before that.
I can also go, but I did go recently.
It's okay. Who needs the most practice? Okay. The person who needs more practice should go. That's really what it is. Who wants more practice? Okay. Sophia or Yichu or Isaac. Brandon, I think you're good, right? Because you also posted some code in the Reddit and all recently.
Yeah, I mean, I don't mind doing it as well. If
Yeah. So you're a backup in case nobody else wants to go. Plus you can also call out the code, when we, have these chunks. So Sophia coded last time. Yichu or Isaac, if you guys want to code, that you should, the first one to grab the screen will actually code today. Yeah. And then you'll pass on to the other person at some point, but the first one to grab the screen, either of you, Isaac, Yichu or Sophia, the first one to grab the screen gets it. Who was it? Isaac's screen. Okay. I think that's how we're going to play it from now on. Okay. Say 3 people and the first person to grab the screen will get it. And hopefully someone will grab it. Okay. Now I fork this so that you can edit the code.
Okay.
That's funny. I think the readability is now lower. Maybe it was the font size or whatever it is that monitor. No, it's okay. It's now I can.
Yeah.
Yeah. Combination. No, it is just a combination of something else. All right. Okay. Now, what is that function that we want to implement? A show animated list. Let's implement that. So copy that declaration line, paste it, adjust it. Show animated list. Where's the declaration? Yeah. Copy the triple click on the line. Yeah. And then go to the end before main. Before main. Yeah. Enter. And adjust it and put this, list double colon in front of it. Not there, not there. Yeah. All right. Okay. All right. Now let's do the body. Now here's what we're going to do. Here, show the animated list. We have the toString. Yes, we have the toString of a list. Yeah. Okay. Here's what we're going to do. Go to the previous line, to line 68, and hit enter. We'll put, what we have in our mind in a comment, and then we'll try and follow it through. Okay, I open a comment and say, all right, in a loop, print the list until the tail well, one sec, okay? Print the list. No, print the list until the tail, or maybe 20 elements. We'll say 20. We'll come back to it. 20 elements or the tail. 20 elements or the tail, or the tail or the 20 elements. And then go to the next line. Go to the next line. By the way, don't use the two. We don't mix two kinds of comments like this, because it is kind of we have to have some semantic tags to these comments. If we're using the two, it's better to use them with meaning. All right. Okay. So in a loop, print the list until the tail or 20 elements. Then sleep for, I think it's 100 milliseconds. Sleep for 100 milliseconds. Reset the beginning of the list to the element after the first, and repeat until either the list is empty or the animation has gotten too slow. Hey, we got a bunch of things there that we've got to kind of work into our code, but I'm positive we can do that. Okay. And the challenge also, I think, is partly to do it within, I don't know, 10 or 15 lines max. I think that's what we should do. So here's what I'm thinking. Okay. We'll print the list. Without any code, just think through it with me and let me know if the logic is not going to work, because then, we should adjust it before we start coding. So tell me, play it out in your head and tell me if it's going to work or not. We're going to print the list. After we print the list, now we hold on to the beginning of the list and we print it. Okay. And then /r to the beginning. And yeah, we'll add that to the comment. Okay. /r to the beginning. Sleep for 0.2 seconds. And then make the list advance to the next element. Okay. And then do the same thing again. I'm going to keep doing that in a loop at least 20 times. Yeah. Or if the list has no more elements, either way we stop, if the null has gotten all the way to the end, and it'll appear to move. However, the sleep duration will keep adjusting. Okay. So initially it'll move fast. So sleep, I don't know, 100 milliseconds. But I think in each round, we'll make the sleep slightly longer. Maybe we'll use an exponential function or something like that, so that it kind of has deceleration. So it starts off by scrolling fast, and then it slows down, like the Wheel of Fortune. Okay. And then, it stops. It stops either when there's a tail or 20 elements have been, actually, it'll just stop when there's either a tail or the velocity, the speed has been, let's change the comments too. You're actually putting all those in comments too? All right, okay. All right, okay. Well, we moved that comment block outside so that we'll start coding it. And then I think I had a chance to explain this to you in a kind of hand-wavy way, but I think the code will be more precise and hopefully be easier for you to critique or say, there's a problem there, it won't work. Okay. Yeah, get rid of that. Okay. All right. So let's say Yeah, okay. Let's say we start with a speed multiplier. Okay, so float speed multiplier equals 1.0. Okay, we start with 1.0, and then the speed multiplier is going to keep on decreasing so that it becomes slower and slower. Speed multiplier. Well, it's
Did I
got
spell that right? I might not have.
Hmm?
Did I spell multiplier right? I might not have.
I'm sorry, what were you saying? Sorry?
Or I think I might have not spelled multiplier right, but it doesn't really matter.
No, that seems, oh, I see, P-L-I-E-R. P-L-I-E-R, isn't that what you have?
Yes.
Yeah, so that looks right to me, but
Okay.
well, it is a font. I told you it is a font. It does look wrong to me, but it is right. It's a T and the L are too similar to each other in terms of that thing or something. It looks wrong to me, but it's right. All right. Yeah, I can increase the font size. That's better. All right. So, all right. So fluid speed multiplier. All right. Now hit enter one more time. No, yeah, on the previous line, actually, say float speed equals float. No, say int, no, it's unsigned long. So say size t interval, size t interval equals, we say 100 milliseconds to start with, okay? 100 milliseconds. We started with 100 milliseconds last time, I think. Let's say 100 milliseconds, okay? 100 times 1,000. 100 times 1,000. 100 times 1,000. Okay, 100 times 1,000. So that is the initial interval. And then we're going to increase it by speed multiplier. And speed multiplier, I think, should be 1.1, okay? 1.1, okay? 1.1. So each time, and call it interval multiplier, not speed multiplier. I think that makes a lot more sense. That's what I was worried about before. Interval multiplier. And then it should be after interval. Interval should be declared first, and then interval multiplier after that. Okay, so that in milliseconds, and all right, okay, that's great. Okay, now a blank line, and then say for size t. No, for no, while while interval is less than is it two? No, hang on one sec. Okay, 2 seconds is 2,000 milliseconds, isn't it? 2 seconds is 2,000 milliseconds. All right, 2,000. Now, how many multiplications of let's do a little bit of math in our heads, okay? 100. We start with 100,000, and we want to get it to 2,000. Okay, how many times do we need to multiply by 1.1? So 1.1 to the x times 1.1 to the x times 100,000 equals 2,000. Can someone solve that and tell me what x should be?
Sorry, I have a question.
Yeah.
Why are we multiplying interval by 1,000?
Good question. Okay. No, I see. Instead of saying 100,000, instead of saying 100,000.
Why? What?
As opposed to what?
Well, why are we doing it at all? Why don't we just say, oh, it's 100 and the unit is milliseconds? Why do we need it to be multiplied by 100?
Because the function that we will be using to sleep to create our sleep of our delay is called sleep, microsleep, usleep.
Okay, so then it's not actually in milliseconds, it's in some.
It is milliseconds. Usleep takes an argument in milliseconds.
Right now, this is a lot more than 100 milliseconds, right? Because we're multiplying 100. We want 100 milliseconds, but we're multiplying that by 1,000.
Oh, microseconds. Usleep is microsleep, not millisleep.
Okay.
Hey, I'm sorry.
Thank you.
Right. So U stands for microsleep. No, yeah. And this is milliseconds. That's why we multiply by 1,000. So yeah, thanks for the comment. Yeah, usleep is microsleep.
What is a micro?
Micro is 1 millionth. Okay, milli is 1,000. Yeah. I think pico is the opposite of something, the next one, next level. I don't know. It's a bit of a pain to keep up. All right, so while interval is less than 2000, I think it'll take a few iterations to get to that. We'll just do this empirically, okay? And we'll cancel things out and say, so yeah, curly braces, right? And then we can put a comment on the while line. So a comment saying, the wheel will, on the same line as the while, we can put a comment saying, until animation slows to 2 seconds or slower. Until the animation interval is 2 seconds, is 2 seconds or longer. Yeah, 2 seconds or slower. Yeah. All right. Okay. All right. So that's what we're going to keep looping until then.
Okay.
And we know it is going to come. It's going to get slower because each time around the loop, interval is going to increase. Okay. All right,
And we
so
needed to change interval to 2 million. We need interval less than 2 million because
yeah, right.
I changed it to 2 million
200
and I'm
times
just
1000 to make the 2000 times 2000 times 1000.
okay. Yeah, that'll be better. Thank you.
Yeah, 2000 times 1000. Thank you, Isaac, for picking that up. Okay. All right. Okay. So 2 seconds. All right. Okay. So here, and also we want to print the list, right? So when we, so what we're going to do is, go to line 82 and hit enter. Go to line 82 and hit enter. And say, right? Node star first node equals node star first node equals head. Okay. Okay. All right. Yeah. All right. So in here, no, inside the loop now. You don't need the blank line actually. Right. All right. So in the loop, what we can do is we can do that for loop that you have there. So essentially what we want to do is for P equals first node. Yeah, that for loop that you have on line 61, copy it and paste it here. Yeah. And we'll say C out for now, right? We'll say C out instead of, no, we'll copy it and paste it there. Don't delete it. Yeah. Yeah, the whole thing, including the null and all. Yeah, clean it up. No, the for, yeah, and then instead of OSS, say C out. One sec, let me take a look. Okay, for node P equals, not head, P equals first node. P equals first node. No. That is correct. Leave that alone. Yeah, P equals first node. And then P arrow next is not equal to null pointer P. Okay. We do need to do a check to make sure the first node is not null. In fact, what you can do is on line 83, hit enter. Go to the end of line 83, hit enter. Yeah, if first node equals null, just return, right? If first node equals null pointer, return null, return immediately. No, don't put a braces and all, we waste a line. And put it one, yeah, you can just put it on, yeah. Yeah, indent in and say return null pointer. Return, that's it, return semicolon. No, I don't think we're doing this. We're just doing void return there. All right, and blank line after that, then we do the while loop. All right, so in the while loop, we're doing, we're printing the whole thing and then that, and then we want to print out a /r to go to the beginning of the line. After the for, we don't need the curly braces for the for, so get rid of the curly braces for the for. Right, now you want to see out a /r and followed by a flush character. So no, /r, /r within quotes, /r within double quotes or single quotes, /r within double quotes, yeah. /r. I think I had this conversation with you before. You were coding and then the / looked to me like a vertical bar. Was that you, Isaac? Is that
Yeah,
you?
it was me. Now it looks like a backslash. Huh.
Well, yeah, it does look like a backslash, but still, it is too vertical to be a backslash to me.
Yeah.
All right. But yeah, it does look like the backslash in front of the slash n you have up there, so that's okay. Right, and then flush, flush, flush. Okay, yeah, semicolon. Now, well, yeah, now we want to get out of the while loop. Get out of the while loop. Outside the while loop. Okay, now what? It's done. No, well, one second. Yeah. No, out after the cout, after the cout. Sorry, inside the while loop after the cout. Now it's printed that, and then it's gone to the beginning. Now we want to sleep for a certain duration. Okay, so you want to say sleep interval. Yeah, no, you sleep interval. This is micro sleep. You sleep interval. You sleep. You sleep. And do we have that unistd.h at the top? Hash include unistd. .h. All right, let's go back to that code. Okay. All right. Yeah, you sleep, and then after you sleep, yeah, hit enter. Yeah, next line. You want to say first node equals first node arrow next. Now, in fact, yeah, put it there, and then what we want to do is, you know, that thing there, you know, a line 85 and 86. If first node equals null pointer, cut it, and put it inside the while loop. Those are the first two things inside the while loop. Yeah, the first two. Yeah, put it inside the while loop. Yeah, indent in, and then a blank line after that too. That'll be nice. Okay, and then you get rid of the blank line on 85 and 86 too. So you don't need those two blank lines. It's nicer and tighter that way. Okay, all right. So first node is had, and if at any time first node is a null pointer, we don't do anything. But if it's not, we print that line, and then sleep for the interval. Oh, we have to change interval, right? And then after first node equals next, you want to say the first node. What is that first node arrow next? What is that? First node equals first node arrow next. First node equals first node arrow next. On the next line, you want to say interval times equals star equals. What is it? Interval multiplier. Okay, semicolon. And then at the very end of the animation, line 97. No, that's it. We get to line 97. No, not there. You can exit inside the while loop. Then it'll just do it only one time. That's it. That's the end of the while loop. Yeah, you can get rid of the blank line. There is a blank line in there. I can get rid of that. I'm running it in my head to make sure it's all working. You should also be doing the same thing and saying, hey, you know what? Maybe there's a hole there. You know, maybe you need to fix something. People have called out, you know, if, you know, do we need to do that and so on? Like Richard pointed out a few things we had to fix last class. Yeah. So I'd like more of you to actually follow what we're coding, and just run through the code in your head and say, well, hey, we forgot to take care of that corner case. And believe it or not, this is going to help you in your final quest too. Yeah, because by looking at the code, running it in your head and saying, well, you know what, we forgot to button up that place, right? We need to make sure that case is covered and so on. Your quest will go through without, all your minis will pass without getting stuck, because you'll actually be, you know, have practiced all that. So please do run the code in your head and make sure, you see. And see, even though it's just a click of a button, think about it. We just have to click the button, the green button, don't do it, right? And see if it works or not. And say, hey, you know what, it's red ink, and oh, it tells us where it's wrong. We can go and fix it. That's no fun. Yes, because as a computer science student, and you know, computer science people in general, the fun is in figuring out what the problem is and not having the machine tell us this is the problem, you know. And so we want to run the code in our head as much as possible and say this is what the output is going to be, and then run the experiment. See, in science in general, not just computer science, in science, there's a distinction between good scientists, good physicists, and bad, in the sense that when a good scientist performs an experiment, They have done the experiment and its variations a million times in their head already. Okay, I've seen this in many times, and I've had the good fortune of looking at good science in action. Okay, so when a good scientist does an experiment, it's very unlikely that it goes wrong. In fact, it's very similar to once upon a time in a previous life. I was having dinner as a magician, and they did a trick. And there's a dinner trick, okay, and they did it to the to my dinner companion, and then the same trick to me, and it worked both times. And so I couldn't figure out how to do it, and I was doing this calculation in my head and say, well, the problem is I think if you practice enough, you can do it with 99.9999% accuracy. And so there's like the slim fraction of the population for whom it'll go wrong, but you'll distract them quickly with another trick. And he said, no, I'm a professional magician. I never do tricks which don't have 100% chance of success, right? Even if it has like an invincible chance of failure, doesn't do it. I don't know how we got started talking about that, but anyway, so that's what we're going for, essentially writing the code so that we get as comfortable as possible with all the different ways in which it can go wrong, but it'll never ever go wrong because we've taken care of all the different cases. All right, so run the whole code in your head. Yeah, that's where we started. Run the code in your head, and I think that's a practice. Okay, run the code in your head many times. And then when they do the experiment, they already know what the outcome is going to be. That is why the surprise, that is why when an experiment does not work, the scientist is like very pleasantly surprised that, wow, even though it was bad that my experiment didn't work, I'm happy it didn't work. In fact, I was the very first time when I was, Peter was here many years ago, I offered him a walnut and he bit my finger. And then it started bleeding and all, and then I don't know how we got started talking about it. We shouldn't waste time. Okay. Anyway, let's go back to this code. All right. So yeah, we should just run it in our head like this, and please practice as much as you can. Okay.
By the way, it should run for 32 repetitions.
Oh, it is 32. You solved the equation? Yes. All right. So I think it'll be 32 will be okay, I think. But 32 but each 2 milliseconds. Is it 1/100th of a 2? Yeah, we are sleeping for how many? 0.2. We're sleeping for 200,000 milliseconds. So how many frames per second are we getting? 8 frames per second. So we're sleeping for 200 milliseconds. Yeah, so it's 5 in 1,000 milliseconds. But we're only sleeping for 200. We're sleeping for 100 milliseconds, are we? Initially.
Initially, we sleep for 100 milliseconds, but we go up to 2 seconds at our most.
Maybe that is too slow to start with, because 100 is, we're only looking at 10 frames per second. Yes, because we'll only have 10 advances per second. I think what we need to do is start it at 20. It's going to get slower and slower. It started at 50,000. Okay, we'll start at 50,000, not 100,000. No, not there. Yeah, there, 50,000. We'll experiment with this and figure out. Okay, what else? 50,000. And it should, oh yeah, we need to print a lot of spaces after the /r. No, before we print the /r, because as the list moves to the left, it'll be, it'll leave some litter behind it. So after the before you print the /r in cout, after the cout, before the /r, print a string with lots of spaces in it. After the cout. No, just inside of the cout itself. The first thing you shift is lots of spaces. A string with like 10 spaces or something. The cout, yeah, on line 90, you got cout, yeah? Not there, it has to go before the /r. Oh, you do have, not there at all, leave that alone. On line 92, I said
92, okay.
Yeah. In fact, yeah, instead of /r, say space /r. I think, lots of spaces and then /r. I think that lots of spaces, and that will take care of, as the list moves to the left, it'll, won't leave the last character behind. It's kind of messy. So the space will kind of wipe things as it moves. Okay, all right. Now and then when it's done, it breaks the loop. You can print an a see out endl after that, just to make sure. Endl. You can see out animation finished. Okay, see out. No, not there. At the end. Not there. Yeah, flush, and then at the end, after the while loop, you see out left shift. And then endl, yeah. And then you can also say, after the endl, you can say see out one more time, and then you can say animation finished. So we have some kind of, it's debugging, right? So we're going to remove that. Okay, and then endl after that too. All right, now you can get rid of the blank lines. We can run it. We'll see if there's any compiler errors. We'll fix it. We should hopefully get some animation of this thing here. All right, now go to the main, your main method. Okay, now instead of, when you print these numbers, don't print don't put 0 to 10. Print, print I times, I times rand. Okay, I times rand. So we just print a random number, but it's going to be, I times rand, and then open, close, open, close. So we're printing a random, it's going to be a list of random numbers, and then I times rand, and then call srand and at the very beginning after list, my list. It should probably be before list, because list might be a constructor. That's a funny thing.
Do we need an include for
put the srand
rand?
before the list, yeah, because it's list is an object, which means it's going to invoke constructor code, and constructor code could have some randomization inside of it. Well, in this case, we know it's not. But if you're creating an object and you're calling srand, srand should be called even before you create the first object, because the first object might have constructor code, which calls a rand. So if you want true randomness, you got to call srand before you even create the first object. Yeah, no, it's time, and then null pointer. Okay, time, and then you pass null pointer to time. No, time, and then a null pointer is a parameter of time. Yeah, all right, semicolon, enter. Yeah. I think that's good. Now, I think we don't need to do that, typecasting and all. It's probably being done automatically, but we used to put that unsigned cast before. We should run it now. We'll see if we get any compiler error. No, not toString. We want to print show animated list. And then we don't need endl. So yeah, we don't need see out and all. We're just going to show. And then no endl after that. Okay. All right, let's give it a whirl and see if it works. Okay, let's fix it. There's an error. What is the error? First node equals first node arrow. Oh, I think it's not next. What is it called? Underscore next?
It's yes.
Run it. Oh wow, that was really fast. It actually did happen. I think something blitzed past the screen. I couldn't tell what the hell was going on. All right, okay. Now let's change the timing. It's a size t interval. I think let's go with 100. You started with 100, 100, and then the interval multiplier. Let's change the interval multiplier. Let's make it 1.05 instead of 1.1. So it's half the speed. Okay, it's got to slow down, and then also. Make the list longer. All right. In our main, it's got only, yeah, make that 20, 30, 25 elements. Okay. All right. And then increase the size of the screen, the console before you run it. Hey, can you increase the font size? So it'll, I think it's not using white and black. It's probably using some gray and black. That's why the contrast is low for me on. Yeah, run it. Let's see what happens. Yeah, oh, you can change these things. Hey, that's really cool. And terminal theme could be made a light theme, right? I think the dark theme is kind of screwing with the. Okay, no, I think I hope it's not green. Let's run it. Hey, well, what happened to the dashes? We're not seeing any dashes. Something's funny. Let's change the.
I thought I saw some dashes, but I could have been wrong.
How about change the interval to 1,000 times 1,000? What's going on here? Oh, because the numbers are much bigger now. Because rand bigger. Oh, I see. 20 random numbers, and this is 20 random numbers.
It should be 25 random numbers.
Oh, I see. So the rands are too big too. You want to make the rands, let's not do rands. Let's not do rands. Print some big number, 3-digit number. I was thinking of a 3-digit number. Rand percent 1,000 should do it really. But I times rand percent 1,000. Yeah, I think that should do it. It doesn't matter because the precedence rules will get it, but still. Hey, that actually did work. It did work. Yes, but we're not seeing null. The last guy should be null, shouldn't it? So the null carriage is not moving along. And then we should fiddle with the timings also.
When we ran it before, I remember seeing the last one being 0.
No, null pointer or null, N-U-L-L. I'm not seeing the word null, N-U-L-L.
Oh, okay.
Oh, we don't have it. We don't have it in our print. When we print, right? Let's go to that show animated list function. We can fix it. Increase the size of the code. By the way, Isaac, you're having too much fun. Who was the next person to code? Yichu, do you want to code again? Or where's Sophia? Is Sophia still here? Sophia, are you there? Sophie's gone? Sophia's gone. She wanted to code, I think.
I can be the next.
Yeah, you can. All right, you can take the code. Isaac will fork it and share the thing with you. Hey, if any of you can get in touch with Sophia via Reddit or other channels, send her an email to come to class and code, because we have opportunities now. We have time and opportunity to code. Okay, we want to wrap up this code, and it's actually fun. It's turning out to be nice. Okay, so please do reach out to her. And maybe she's just taking a short break. Okay. But you two take the code, okay? As soon as you're ready, we'll start coding. Yeah, I think we'll fiddle with the timing. By the way, extra credit. There's an extra credit opportunity staring us in the face. Well, when you run it one more time, I'll show you. Right? Yeah, increase the size of the. Yeah. Can you run it? Let's see. Run it. Let's make sure you can run it. Okay. Oh, all right. Let's go to the show animated list. Show animated list. Where is that show animated list? Okay. What we want to do is /R. No. Hang on. Oh yeah, outside the for loop. After the for loop. All right. So outside the for loop. Oh, I see. Yeah. All right. So where you say C out, line 92, C out. And after the double quote, say N-U-L-L. Okay, I think that will take care of it. After the not there. After the first double quote, after the first double quote, inside the string. Okay, so the last thing will be null, uppercase N-U-L-L. Okay, so that shows that that's the last element of the list, and it's a null. Right. So if you run it now, we'll have the null as the last bogey. All right. Now the extra credit opportunity, if you're taking note, all right, if you want to have some fun doing this, you'll see you run it again, YouTube, you'll see the animation is kind of jerky. Okay. Keep running it a few times. Okay. Why is it? Yeah. See, it's kind of jerky. And that is because we have these 3 digits and 4-digit numbers, and the whole thing is moving out. So it's like 4 digits scrolling out at one time, 4 digits scrolling out at one time, 3 digits scrolling. So it's kind of jerky. Is everybody okay and agree with me so far? Yes or no? Hang a thumbs up if you agree with me. Yes, I'm getting fire. All right, okay. So the extra credit opportunity, if you choose to accept it, is to just craft a version without much more lines of code. Okay, do your own version. Maybe it uses a helper function or whatever it is. I don't know. Maybe it is. It shouldn't take more than 4 or 5 lines more than what we have. However, the animation should be a whole lot more smooth, meaning that it's not going to jump one whole number. If the number has 5 characters, like 37212 dash, okay, that's got to scroll out. What you would do is scroll the 3 out first, then 7. So you're going to do 1 character at a time with the sleep, right? So the motion will be smoother. Okay, you'll actually see the noticeable difference. So please do that. It'll actually be very much fun and satisfying to watch as you take this animation, make it smoother, and run it. Okay, and that is a sure extra credit opportunity if you do that. If you take this code and do that, okay. But we're not going to do that for the game. for the game, we'll just do this jerky animation and do it. Okay, so we've got this list animation. Oh, why? But it didn't slow down. It didn't slow down. Why didn't it slow down? It should slow down. Okay, let's create a loop. Okay, go to your main. Go to your main. All right. Now, here's what we want to do. Yeah. We want to take the last element and put it to the first element. Okay. All right. Here's what we want to do. Okay. Okay. Hit enter. Hit enter. Right. So say my list dot convert to a ring. Okay. Convert to loop. Convert to loop. Convert underscore to loop. Convert underscore to loop. Okay, and we're going to implement this function. Okay, open, close, semicolon. All right, now, let's go to the class, declare this function. Okay, go to the class and declare this function. By the way, all of this should be less than 100 lines of code, I think. My guess is that the total length of all of this should be less than 100 lines. All right, after show, but before, after push front, I think this will go after push front. Hit enter. And say void convert to loop, void space convert to loop, Okay, now let's define this method. Okay, so let's define. No, before it should go before toString. It's before two. No, I think it should go before animation and toString. What is before toString? Oh yeah, it should go there. It should go there. All right, hit enter. Yeah. No, after push front. That's where you had it before. Yeah. There you go. All right, so void convert to loop. Okay. All right. Okay. Now let's put comments right on top of this function. Right. Go to line 55. Hit enter. All right. So you're going to say make the list a loop by connecting the last node to the first node. By connecting the last node to the first node. Okay, that means the list does not have an end. You can just keep going round and round and round. It's an infinite loop. Yes. Okay. All right. So here's what we're going to do inside of this loop. All right. So say node star p equals head. Uppercase N for node. Okay. I think it's no. Is it underscore head? Maybe it's, I don't know. I've forgotten. Is it underscore head? Oh, wow. We got like mixed notation in the class. No, go to the class def. We have just head and then underscore. Oh, node has underscore data underscore. Oh, and here we just have head. Okay. Yeah, it's kind of, see, that's why we should be consistent. All right, that's fine. Yeah, let's go to the code and say, yeah, A equals head. Okay, enter. Now what we're going to do is actually keep moving from, from P until, keep on moving forward until we hit a node where the next guy is null pointer. Okay, so we're going to say while P arrow next. P arrow. Yeah, P arrow next. P arrow underscore next. Yeah, is not equal to null pointer. We don't need braces. While is not equal to null pointer. And put spaces around the not equal to. Yeah, enter. P tab in and say P equals P arrow next. Yeah, enter. And then one more enter and then backspace. Now we know that we've reached a node and the next guy is a null pointer, right? Well, now what we're going to do is we don't want the next guy to be null pointer. We want the next guy to be head's next guy. Okay, so we're going to say P arrow next equals. equals head arrow next. Okay, that's it. Now, there's one situation where, you know, it will not become a loop, where you actually pass it an empty list, right? With a head with a null pointer, right? Add head with no elements, and you and say convert this to a loop. It's not going to work, right? So that's something that you can touch upon in the forum. Okay, so you can put a comment on top of this function. Yeah, will this work on all loops? Are there any corner cases where it won't work? Discuss in the forum. Okay. On all loops, on all lists, on all lists. Question mark, question mark. You can discuss any corner cases where it fails in the forum. Again, so the reason I put that comment there, actually there is no reason. I put the comment there and then I'm thinking back to the reason, backwards to the reason. This is actually useful because by forcing yourself to think of the corner case in which that won't work, you'll be helping yourself in quest number 9. Because when you implement functions in quest number 9, there's going to be so many corner cases. And so you're going to be doing exactly this and say, hey, will it work everywhere? Maybe there's one situation where it won't work. Okay. So that is basically what you're going to be doing as a programmer a lot of times. You know, so it just becomes subconscious, so you're not aware of it. But that is basically what all programmers do, right? Software designers. All right, okay. Now, if you run your code now, I believe it should just keep on printing until it gets low. What is this? Oh, no, convert to loop is a class method. Okay, it's a method of the class. Yeah. So void space list double colon convert to loop.
Void space.
Oh. List double colon. Uppercase list. List double colon.
Colon.
Yeah, colon, 2 colons.
Yeah.
Yeah. Get rid of the space. Get rid of the space after that. I think if you run it now, you should just see that animation keep on going. Okay.
Oh,
no, wait a sec. There's something wrong there. Okay, kill it. Stop. Hit the stop button. Oh, I see. The reason is because we are. Oh, no. Why? No, something is wrong here. Convert to a loop, and then we get to the first element. Oh, I see. Oh, wait. Oh, one sec. Okay. I see, it's gotten into that loop. All right, so we need one more condition for it for us to stop. Okay, so go to that show animated list function. Go to the show animated list function. Here, while interval is less than 20, yeah, that, or no, why is it not slowing down? It has to slow down and stop, right? Oh, no. One sec. I'm just thinking through this. You should also be thinking through this, all right? But however, even the very first loop, it's so long because there's no end. It's just printing out the same thing. So where we go for p equals first node, p arrow next equals null pointer. Right, p arrow. All right. So here's what we're going to do. All right. Give me one sec. I'd go to line 100 and hit enter. Yeah, now say size t, num elements printed, elements printed, yeah, whatever. All right, elements printed equals 0. Okay, all right. Now make the for loop a block, so curly braces for in the for loop, make curly braces. Yeah, after the cout, yeah. Now what we want to do is if plus num elements printed is greater than how 3 digits. Let's say we print 20, okay, max. So let's say 20 break. Okay. Now you don't need curly braces for the if statement. Yeah. Okay, now I think that should work. Okay. It should get slower. It should get slower, by the way. Is it getting slower?
Yeah.
Okay. What is it? That null thing is there's a bug there. Okay, that null shouldn't be showing up there. So something funky is going on. But anyway, what time is it now? You know what? It's 7:20. I have half a mind to let you guys either debug this or work through this if you want. I can work through this if you want, right? Here's your choices. Considering this is the last 20 minutes or 30 minutes of this class, here are your choices. And you should if you're totally silent, I have no idea what to do. So you guys have to pick one of these. Okay, choice number one. I work through this code just like this, and I'll talk through the code. You two will do it. And then we're going to do the game in main. We'll just say, all right, here's what we're going to do. It's like 10 lines of code. Do that. Number two is you guys could say, we're going to fix that null thing bug, null pointer, null word at the end, right? What's it going? It's something funky with the animation. I'm going to fix that. Or we could just continue with the game with that bug there. Basically, I'm going to talk through the code with Yichu. That's the first option, right? Where the extra credit part of it, that you're going to fix that trading null bug when you fix it, like Brandon did, right? You're going to say, hey, I did that and I took care of that. That's gone too. So you're going to fix that and post it on the forum. Okay, so those are all the options available to you. Or you can just basically have time to do the main yourself too, which also is an option if you want to do. Which one do you want to? Right? Do you want me to talk Yichu through the rest of this code? We basically leave the null bug there for you to fix. I won't fix it, but I will assume that one of you is going to fix it, and then we'll go into main, okay, and do this game. Are you guys okay with that? Or do you want to fix the null bug yourself for the next, I don't know, 10 minutes? Because if I could say you could do it for 10 minutes, so it'll probably be 15 minutes then, and that's the end of class. And so we'll be winding down. So
I'm
that is
thinking-
the reason.
I'm thinking just going with the first one, and then we can just do the null bug later.
Okay, thank you, Ben. Okay, all right. So let's just go and do the main. Well, maybe we'll even play the game, and then one of you or many of you are going to fix that null bug and do it later. All right, okay. So main. Now let's get rid of all that. Line 126. Get rid of 126, and then the other thing we want to do is and get rid of everything from list to my list, everything from my list to my list until the return. Okay, all right. Now let's put comments there. Let's put comments at the top of main, at the top of main. Let's put comments, and say in this game, we will create a list of random numbers. A list of random numbers, okay? And this list may be any length from 10 elements to 1,000 elements, okay? 10 elements to 1,000 elements. 10 elements to 100 elements. How about this? 10 elements to 100 elements. Any length from 10 elements to 100 elements, chosen randomly. Chosen randomly, chosen. Okay, all right. Now, approximately 50% of these lists will get turned into loops. Approximately 50% of these lists will get turned into loops. Approximately APPROXI.
OXI.
MATELY, right? And you know how to do that? Basically, you're going to do a random number and see if the random number is odd or even, right? Or even say, if rand is greater than 0.5, I do one. Otherwise, basically flipping a coin, right? So, and say 50% of these lists, will get turned into loops. And you know how to turn into a loop, right? You're going to call that function, convert list into a loop. Okay, all right. Now on the next line, now we enter the user play loop. Now we enter the user play loop. Okay, right? On the colon and enter. And yeah, right. Now what we're going to do is say within comment say number one, first, we show the animated list. And it'll show 20 items, and then it'll also slow down and stop. Okay, good.
Show
All right.
20 items.
Show the animated. Yeah. No. I'm sorry. We show the animated list. That's it. Yeah. And yeah. Enter. And then number two. Ask the user whether 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 okay, whether the animation represents a loop or a list. Represents. List. Okay. All right. And on the next line, you say accept input, accept three forms of input. Okay. Accept the number three, item number three. Right. Accept three forms of input. Either a list or a loop. They both begin with L. Okay, list or a ring. Okay, how about a list or a loopy or not? Okay, loopy or not? Okay, loopy or not? Okay, L or N? Okay,
Loop.
Yeah, whether the list is a loop or not. Or yeah, I think what we should do is call this game "Are You Loopy?" Okay, so I put go to line 116 and hit enter. Yeah, this is the code for. This code is for the game Are You Loopy? Code is for the game Are You Loopy? Right? And then make that, within quotes in uppercase A. Okay, question mark at the end. Okay, all right. Now accept three forms of input. So you say yes, no, or enter. Yeah. Yes, no, or enter. Yeah. Ask the user, am I loopy? Right. Ask the user, am I loopy? Right. Am I loopy? Now, as on line two, ask the user whether. Right. That's all crazy. Ask the user, am I loopy? Within quotes. On line 123. Clean it up. No, line 123. Cleaned up. Ask the user. Am I loopy? Within double quotes. Am I loopy? Question mark, and then space, and then space within parentheses. You can say yes, y/n/enter. y/n/enter. Yeah. I think we should just say, yeah, I think why. In fact, you should put that within parentheses and then put the question mark at the very end, I think. Okay. And then what we should do is, all right. So now, so what we also, we have to tell the user enter means scroll once more. Okay. So I think what we have to do is y/n enter. Yeah, but no, on item number two. On item number two, when you say y/n enter, put that within within parentheses. Put that within parentheses. No, on item two. I'm sorry, Yechu. Right, I'm just jumping all over the place. All right, go to 123, line 123, and say y/n enter. Put that within parentheses.
Why?
No. Where you already have. No, you have y/n/enter. Put that within parentheses. Put that within parentheses. No, not quotes, parentheses. There you go. All right. Now after enter, space, after enter space. No, right after that, after the word enter, say space, dash, enter will scroll the list one more. Enter will not hyphen, not underscore, dash. And then space after the dash. Yeah, space after the dash. Enter will scroll the list one more time. Scroll, S-C-R-O-L-L. Yeah. One more time. Okay. All right. So basically, here's the whole game. In case we don't complete it, this is what you're going to complete and share on the Reddit. Okay, and it's going to be fun. You're going to somehow, gamify this whole thing. Even if we don't do it, you do it, right? Okay. So what we do is show the list and then say, am I loopy, right? And then we would have seen that list, and then sometimes we won't see the whole list. Maybe there's 1,000 items, and then the animation stops, and we don't have a chance to remember all these things. Okay, it's going to be funny because sometimes you may be able to say, hey, I saw 1, 2, 3 go by this time, and then it's coming back this side, right? So it's loopy. So sometimes you won't know, you have to guess. And so, but what you can do is say, yes, it's loopy, no, it's loopy, and not loopy. Those two end the game. Third is just hit enter. And when you hit enter, it's just going to go back to the same location, right? Basically, you have to use that cursor positioning trick, okay? Get back to the same place and then do another animation, starting at the end location, okay? Keep on doing it so that each time you hit enter, it just scrolls more and more and more and more and more. So you can actually keep on scrolling until you determine whether it's a list or a loop, okay? And I think it'll be, and because you see that animation and slows down, so you can actually keep looking at the pattern and say, hey, 742,357, okay, or something like that, some bunch of numbers. And then I scrolled many times and I got the same number, same sequence again. So it must be a loop, okay? So, and then at the end, you can say you got the right answer, but you took like 5 scrolls or 20 scrolls, 30 scrolls, okay? So the number of scrolls before you actually give the answer could be a very good indicator of the level of gameplay. Do we have time? We actually have 10 more minutes at least, okay? 12 more minutes. Why don't we try and finish it, okay? So let's do this. Okay. Yeah, except no, number three, instead of accept 3 forms of input, you say, if the user hits enter, if the user hits yes or no, the game ends, depending on whether they were right or wrong, right? The game ends announcing, the game ends after announcing whether they won or lost, okay? Depends. Oh, I see. If the user hits Y or N, it enters Y or N, not hits, right? Enters, because you can't have enters Y or N. The game ends. Instead of depends. So the game ends after announcing whether the user won. Okay. If the user won. On the next line, you say, if the user just hit enter, then we use the cursor positioning trick to go back to the place where we printed the list. You can always print, show the list at a fixed space, right? And say, where you say do the show animated list, you can always say, I'll show you how to do that, right? Okay. Then you just scroll the list one more time, starting at the new cursor position, new beginning location. Okay. More time, starting at the new cursor position. So in fact, that means that show animated list should kind of retain the cursor position. All right. So there's a couple of things we need to do.
Cursor C.
Starting at the new, should we say cursor? Yeah, say cursor. Cursor position. Or CURSOR. Now let's go to that show animated list function for a second. All right, here, what we'll do is, right there, hit enter. And then say C out, one more enter. And say C out left shift We'll always go to a fixed place on the screen where we do the animation. Okay. So I think so that way we don't have to worry about a lot of these things. Yeah, thank you. Put a space there. Right. See out, say within quotes, say /033, open curly brace. No, backslash 033, backslash 033, open square bracket. Can someone tell me, no space after the 033, open square bracket, no close square bracket. Okay. Can someone tell me what the code should be to go to row 0, column 0, row 0, column 0? Oh, you can basically 0, semicolon 0H, 0, semicolon 0H.
0, semicolon 0.
H, 0, yes, and then 0H. Is that correct? Can someone verify this, please? I think Josh was here. He was able to verify this before. Richard could possibly do that really quickly, and then do a flush at the very end. Do a flush at the F. Yeah, not there. Left shift flush. Left shift flush. No space, and then uppercase H, not lowercase h, and then nothing else. No. I don't think that works. I don't think that works. Outside of the double quotes. No, not /F. Outside of the double quotes, yeah, left shift flush. No. Left shift flush. Okay, 2 less than signs.
Oh.
Semicolon at the end. No, just semicolon. Right, and put a comment on that line saying always print. No, on the same line. Always on the same line. You can say always print the list on the same line. And one more thing we need to do is instead of saying node star first node, let's say static node star first node. Okay, static node star. No, you don't. We still need node star. Yeah, and then say static in front of that. Static in front. No. Static in front of that. No. Okay, now here is a go to the previous line, hit enter. Go to the previous line and hit enter. Okay, put a comment there to do, right? Again, what does a static thing mean? Okay, now we have not talked about this in any of our classes before, in none of the lectures. Static in this context means something completely different. It just means that every time you call the function, it's going to retain the value, but we've not talked about this. It's like a class variable. However, we know about static variables because in question number 7, you use population, which is a static member. Yes, retains value between multiple objects. Now, static, a variable inside of a function, is a really carryover from C, right? From ancient C days. So Richard probably knows. So static means when you call the function many times, it'll retain the last value it had. So it's like the cursor. It's not the first node anymore. So let's, instead of calling it static node star first node, we will call it static node star cursor equals head. On line 99, cursor. CURSOR. Okay, and then interval, and then instead of first node equals null pointer, you can say cursor equals null pointer. No, not interval, not. Yeah. All right, because we're running out of time, I'm kind of a bit jittery here. Okay, and then okay, so it's just going to go all the way through. Now, one more thing. Okay, we're printing the null at the end. Why is it printing the null? Okay, so I know one sec. Okay, it's going to for first node until it gets to null pointer, and it prints null at the very end. But then when it scrolls over, why is it null carrying? Oh, I see. The null should, but the null should be moving to the left. I don't see the null moving to the left. That's why. Oh, and then a /r and a flush. Sweep in. Oh, I see. Because we're not printing a new line at the very end. No, go one. Scroll down a bit more. Scroll down a bit more. Oh, we are printing a new line at the very end. Get rid of that animation finished. Oh, it is printed. Run it one more time. We'll just see if it. No. I see. Oh, gee, we changed things. All right, the first node, change that first node to cursor. There's a first node somewhere. Okay, there's a null pointer. Yeah, again, first node equals first node. Yeah, cursor equals cursor arrow next. Okay. Run one more time. Something is funky. Why is it not working at all? In our main, where's our main? Where's our main? I think we're not doing anything in main. That's why. Oh yeah, we're not doing anything in main. Why is it we're not doing anything? Oh, we're not doing anything in main. We need a really quick list here to actually do an animation to see if it works. That's okay. We'll just go ahead and code this game. Okay. So see out. Welcome to am I loopy? See out. Well, welcome to am I loopy? Endl. Okay. And then say instructions for this game. I will show you a list. And you must tell me if the list is loopy or not. I will show you a list, and you must tell me whether the list is loopy or not. And then do two endls. List is, and you must tell me whether it is loopy or not. You must tell me whether it is loopy or not. Whether WHETR, WHETHER, it is loopy or not. It is loopy or not. Right, question, and then period, full stop, and then endl, two endls after that actually. No, not question mark. Yeah, and then two endls, yeah. And then on the previous line, am I loopy should be in uppercase so that it's like it's the name of the game. Am I loopy? Yeah, okay. Okay, all right. Now, what else should we do? Now, the first thing we want to do is construct a list. Okay, so size t, length equals what was it we said? 10 plus rand percent 100. Yeah, put spaces around the plus. Okay, so you may have a list that is only 10 elements long, or it may be up to 110 elements long. Okay, all right, now enter. For size t, I equals 0, I less than length, I plus plus. For size t, I equals 0, I less than length, I plus plus. I plus plus. And get rid of the spaces before the semicolons also, it's nicer. Before, yeah. Yeah, all right. Now, what we want to do is we want to say list.pushback, my list.pushback, my list on the next line, my list.pushback, push front. What is it we had before? Rand percent 1000, yeah? 3-digit number, up to a 3-digit number. Rand percent 1000. Rand percent 1000. Okay, push front. So we have a list now that has up to 1,000, up to potentially up to a what is it? No, length. Like, oh no, that's correct. Okay, the number inside should be up to 1,000, but the length is up to 100. Okay, that's correct. Okay, now what we want to do is we've got the list. Now enter one more time. If rand percent 2 equals 0, or rand, yeah, rand open, yeah, percent 2 double equals 0, and put spaces on both sides of the double equals. Yeah, on the next line, no curly braces. Yeah, next line, you can say my list dot convert to loop, or whatever that is. Convert. When you use 50% of the time, your list becomes a loop. Yes. Okay, now enter. All right, one more enter. Now you're going to enter the player interaction loop. Okay, so no, you don't need 2 blank lines. Only 1 blank line should do. So now you say while. For now, say while true. We'll come back to this later. Okay, while true, and then curly brace at the end. And say is the following list loopy? Is the following list is no, see out. Left shift. Is the following list loopy? No. What we should do is, first we should do is, I'm saying before the see out on the previous line, hit enter. and say mylist.show animated list. Mylist.show animated list. And then, you know, in the show animated list, go to that place where in show animated list, where we do the cursor positioning, go to row number 5, okay? Because, you know, first you're doing some COUTs and all. So we'll start the list at row number 5. Yeah, go to in show animated list, go to the function show animated list. Yeah, where it says row number, oh, I see, row semicolon column H. Can someone please find out what the ANSI code is? What should we output so that we go to row number 5, column number 0? That's what we want to do, right? Can someone please look up Google or somewhere, or even the previous class, to find out what the escape code is, to say, go to row 5, column 0. Actually, if nobody's interested, we don't even have to do the rest of this class, okay? You can actually complete this and post it in the forum, and it may be fun, okay? We're almost at the very end of both, you know, we're at the end of class, but we're actually at the almost at the very end of this code. And it is very tempting for me to complete, by the way, okay? There's like 5 or 10 more lines of code and we're done. And some debugging, it's going to be juicy. I have half a mind to actually leave it with you to say, and in fact, that may be a bad, not such a bad idea, because if you guys are not able to do it or want me to do it, we can have a class on Tuesday, okay? The final is on Thursday, isn't it? So we can have a class on Tuesday and we can wrap it up and play a few rounds of this game too. Okay, so how about this? Because we are at the end of class, I'm going to leave it here because you guys seem to be out of energy at this point. But correct me if I'm wrong. You know, if you want to do it now, I'm happy to do it. But if not, I'm going to be looking forward to you, because I've, you know, described the gist of the game and everything is in there. So you can take this and complete it like Tug Zoe and Brandon, all these guys I have done in the past. But take this game, complete it, play a few rounds maybe, or release something so that I can play it. All right, and have fun. And I think there's more than, you know, not more than 10 to 15 lines of code left for you to do this, and maybe a couple of very nice, interesting, looking forward to, like, you know, interesting, juicy debugging opportunities you may get out of this too. So I think I shouldn't eat your whole cake at this point, okay? Because it's the last lecture and all. However, I'm happy to have another class in week 12 on Tuesday. You guys have to let me know. If not, I'm going to be looking forward in the forums to see someone fix this code and, you know, do that. Is that okay with you? Give me a thumbs up or something. It's not a huge number of lines. It's 150, maybe 7 more lines or 8 more lines. You have it done. Completed game. Actually, a fun little game too, right? It'll actually show you a list and you got to do this. And there's a bunch of extra credit opportunities, smoother animations, questions to answer. So I think we did a, you know, reasonably fun. We didn't get to the very, very end of this game, which maybe is not such a good idea that we got to it, right? Because that would suck the fun completely out of this. So I'm glad that we're actually able to leave a little bit in your hands at the end of this class. Was this entire course useful to you guys? Was this useful? Did you get any interesting stuff out of it? Thank you, Isaac. Okay, Brandon, very yeah, thank you very much. And this class, was this class a generally useful class? We did a bunch of stuff using lists, different kinds of looping and all these guys. Isaac, obviously, because you got live coding. You did live coding today, yes? Yeah, okay. All right. So and live coding has been fun for all of you. Yes, you two did. Was this fun today?
Yeah.
Doing this? Yeah, great. And also useful too. Useful too. And I actually look forward to all of your, you know, modifications of these things. You know, when Tug Zoe and posted this game, or Richard posted that thing that, you know, oh, yeah, I have a lot of time to try these out. Basically engage in your thinking, right? Commune with you and say, hey, you know what, they did this, let me try it out and see what they were trying to do. It's great fun for me too, right? So thank you all so much. Thank you for your patience, with me as I'm, you know, blabbering on and on about lots and lots of things, only marginally connected sometimes, especially people like Richard, who also have a job and is still attending until the very end now. So thank you all very much. I hope to see you all at some point, maybe in a 2B, if you do my 2B, and I'll see you in a virtual catch-up, although we don't have lectures. I don't think we'll actually have formal lectures anymore, because next year, you know, if you do continue in my track, it'll just be 2B and 2C. I'm not doing any, you know, face-to-face there. It's all going to be completely online, and you'll be questioning, obviously, but we'll have, you know, virtual catch-ups and, you know, maybe meetings, optional meetings on request. But otherwise, it has been a great pleasure for me to, you know, be your prof this quarter. We had a great time. I had a great time looking at your posts or your, you know, progress. Thank you so much to Caitlin, who actually absolutely had no obligation to attend any of these classes or even be part of the Reddit and help you guys out, okay? She completed 2A last quarter, but maybe you'll run into her in 2B next quarter. But thank you especially to Caitlin for coming along. Thank you. Yes, we love you too. And hopefully we'll see a lot more of you. All right. So thank you all. And I hope to see you all. Best of luck with everything. Okay. And don't hesitate to reach out, me, Caitlin, Josh, and for any help that you guys need. Okay. All right. Best of luck with everything. All right. I'll see you guys later. Bye.